To lock your car but don't remember until all the way across the parking lot. Isn't it nice to just press a button on a key fob rather than having to walk all the way back to your vehicle? This is the convenience that solenoids offer industries. In my speech, I would like to talk about the importance of solenoids to industries and talk about how these devices operate. I work for Hershey's, Robinson, Illinois, and we use solenoids in order to start and stop our processes. I also go to Vincent's University, where solenoids are used in my mechatronics class as part of the curriculum. Solenoids are useful in industries, and these simple devices can be used for a variety of applications. In my speech, I'd first like to talk about what solenoids are and what varieties are often used. I would then like to talk about what these varieties are used for, and third, talk about how solenoids work and what warning signs you should look out for in them. Solenoids are often used in industry to automatically spool directional control valves used in various processes. Mechatronics professor Timothy Hedrick describes solenoids as electrical mechanical devices which use electrical energy to magnetically cause mechanical movement. The second edition of Robotics Theory and Industrial Applications by Larry Ross describes directional control valves which solenoids operate as being used to start, stop, or reverse fluid flow without creating a significant change to pressure or flow rate. So you see here, this is a solenoid attached to the directional control valve, and this is an internal view as the solenoid opens and closes the flow for this fluid. Solenoids used in industry include the normal on-off type, variable solenoids, and proportional solenoids. The 7th edition of Electrical Control for Machines by Kenneth Rexford describes the on-off type of solenoids being used for the traditional type of solenoid valve to position the spool in one of 2 or 3 discrete positions. Rexford says that variable solenoids are used when it is necessary to position the spool at an infinite number of intermediate positions, and Rexford describes proportional solenoids as operating much the same way as on-off DC solenoids, but that proportional solenoids vary their current in order to vary the force they exert. Now that I've talked about what solenoids are and what their common varieties are, I would like to talk about what they are used for. Solenoids offer the ability to remotely operate valves and robotic arms which enable industries to automate their processes. The type of solenoid used should be based on the task at hand. Rexford's Mechanical Control for Machines describes proportional solenoids as being used for applications where relatively large amounts of spool movement are required. Rexford tells that variable solenoids are useful to provide both directional and flow control, and the on-off solenoids are the most common type of solenoid used in industry, and Ross's Robotics Theory and Industrial Applications describes the 2-way valves they operate as simply providing flow or shutting it off. They describe the 3-way valve solenoids operate as being used to either shift between 2 sources of pressure or to direct pressure to alternate devices. Solenoids can be used with a variety of other components to create efficient and accurate automation. A maintenance technician may commonly create electrical ladder diagrams such as these and pneumatic diagrams such as these to describe circuits used in industry. Professor Adam Beasy from Vincent's University often uses control relays, push buttons, and pneumatic cylinders in order to describe the operations of solenoids in his mechatronics class. So, knowledge of the operations of valves and how solenoids work allow maintenance technicians to use these as a guide to help them troubleshoot. Though most industries today use programmable logic controllers or PLCs in the place of control relays, and they will do the same process, but it allows them to keep everything a lot more confined. And now that I have talked about what solenoids are and what they are used for, I'd like to discuss the operation of the solenoid itself and some common warning signs that you should look out for in them. So solenoids are relatively simple yet effective devices. They can be efficient to use, and there are some warning signs that can lead to some common problems. Solenoids harness the power of electrical energy to create mechanical movement, and according to Electrical Control for Machines by Kenneth Rexford, the basic parts of a solenoid include its frame, plunger, and coil. To summarize Professor Timothy Hedrick's description of how a solenoid works, the coil will be energized, and as electricity flows through the coil, it creates a magnetic field. This magnetic field will pull the plunger in through the coil, and as the plunger pulls into the coil, it will move the spool in the directional control valve. Adam Beasy says that the forces of a solenoid can be rated as low as fractions of an ounce and as high as almost 100 pounds. Maintenance technicians can usually find the problems of solenoids acting up from common warning signs. The solenoid troubleshooting page from Ross Deco Company's website explains that the coils the company makes are rated up to 221 degrees Fahrenheit. So a hot solenoid does not necessarily mean a bad solenoid, though the heat of an overheating solenoid can show some problems. When the coil of the solenoid is energized, it pulls a massive amount of current called inrush current. This current creates a lot of heat, but whenever the plunger is pulled all the way into the coil, the current is lowered into holding current. Though if something is to block the plunger from going all the way into the coil, that inrush current can overheat the coil, which will burn it up. Ross Deco Company's website explains that overheating can also be caused from things such as too fast of a cycle rate, too high ambient temperature of the solenoid, and overvoltage. Overvoltage can also cause the solenoid to pull in with too much force, which can cause it to break apart. Or if you bring in under voltage or too little voltage, then the plunger will not go all the way into the coil, which will cause the inrush current to then burn the coil up. This is why it is very important for the solenoid to pull with relatively the same force that is required of it. So to review my main points, solenoids are electromechanical devices that come in common varieties. Solenoids allow industries to automate their processes because they can be remotely controlled, and solenoids are simply effective, but they do have common problems. Solenoids are useful in industries, and these simple devices can be used for a variety of applications. Just as key fobs make locking your car from a distance simple and easy, solenoids allow for industries to remotely and effectively control and streamline their processes to save and make them money.